This lesson is going to be talking about literal equations. Our essential question today is, how do you solve literal equations, and why is it helpful to know this? Why would we need to know how to solve a literal equation? So the first thing I want to do is make sure that your notes are set up, and I want to define what a literal equation is. A literal equation is simply an equation, right? No duh. An equation that has two or more variables. Okay? A lot of times we think of literal equations as being formulas. Formulas have lots of variables in it. We can even think of our linear equations, y equals 2x plus 3, as being a literal equation. And we already have experience solving those literal equations, those y equals 2x plus 3, when we rearrange them from slope-intercept form to standard forms, from standard to slope-intercept form. We've already been working with that, so this shouldn't be too difficult. The one thing that I want you to think of here is, just like any equation, when we rearrange or do something with it, we're always doing inverse operations. So when you look at a variable and you're not sure how to cancel it out or move it, you need to think about what is the inverse or the opposite operation that would cancel it out. So in this first formula, I want you to recognize that this is the area formula for a rectangle. And I want us to solve this equation for W. So basically I want to rearrange this for W. You do this in science, and you may not realize it or may not do it a mathematical way, but we're still solving for it. So if I want to solve for W, I need to cancel out the L. So this is L times W, so the opposite would be to divide by L. And so W is simply A divided by L. And that would be solving the equation for W. We're basically just rearranging it so W is by itself. In the next equation, I want to solve for R. Okay, and I'm just highlighting it to maybe help it stand out a little bit so that we know what needs to stay and what needs to go. This is our simple interest formula that you may have seen before, simple interest. Okay, and I want to solve for R, so I need to cancel out the P and I need to cancel out the T. This is all multiplying, so because it's all multiplying, I can cancel out the P and the T at the same time. So what's the opposite of multiplying? It would be to divide. So I'm going to divide both sides by P. So that cancels that out, and we get R equals I divided by P times T. And there you have it. Okay, this one hopefully is really easy. We're solving for C. This is involving adding and subtracting. To cancel out the R, don't look behind the number or the variable, look in front of it. So we would say minus R. Okay, so that gives me P minus R equals negative C. Now we know that if we have a negative C, we're not finished. So to get rid of that negative, we basically need to, well, divide or multiply everything by -1. So it would be negative P plus R equals positive C. Okay, next one. This is our surface area formula for a cone, for a cone. Surface area for a cone. And we're going to solve for L. Now this has a little more work to it. Okay, this is kind of like a two-step equation. One way to look at this would be to think of this like S equals 5 plus 2L or something. We're going to do basically the same steps. So we're going to start by canceling out this pi r squared. I'm going to subtract it because it's positive. So this gives me s minus pi r squared equals pi r L. Okay. Still trying to solve for L, so now we're going to divide because that's the opposite of multiplying. Okay. And so L is equal to S minus pi r squared divided by pi times r. So a few more steps, but it's just like looking at a two-step equation. Okay, the last one I want to look at is another area formula. This would be area of a triangle. And I want us to solve for h. So how would we cancel out 1/2? Let's start with that. So when we have that number, let's take care of that first. We are going to multiply by the reciprocal. So that gives me 2a equals bh. And now we simply divide by b. So again, we're just doing inverse operations every single time. H equals 2a divided by b.